Hi, this quick video is created to help us understand how to use Solidworks to analyze a frame. Now the frame that's shown on the screen here is from MC 300, problem set 3. Specifically this is from semester 17-1. It's a jib crane. Now this particular frame is composed of multi-force members such as C, D, E, and two force members, A, B, BD, and BC. That'll come into play when we build this model here in just a moment. So open up SolidWorks, create a new part, and we're going to be using Weldments and Simulation, so make sure that those two tabs are showing. If they're not, just right click on any tab and make sure that they are selected, Weldments and Simulation. Weldments are based on sketches, so we're going to create a new sketch. We'll just create it in the front plane, and we'll begin drawing the basic shape of this crane. Now you'll notice that this is currently not perfect, but that's okay. We'll use some features here in just a little bit to help us tighten this sketch up. If we press the F button, we'll see that we'll zoom in here real quick. And let's just take a look at what we've got. So it looks like B and C need to be in vertical alignment, and B and D need to be in horizontal alignment. So we can select these two joints and say vertical alignment. We can make sure that these two joints are in horizontal alignment. Now this tells us that it didn't like that. That's because we had already defined those. Control Z will undo that. I think I had actually, okay, those are vertically aligned, and let's just double check that these are horizontally aligned. Alright, there we go. I obviously had something else clicked at the time. It's alright. Okay, we also want to make sure then that these two lines are collinear. So they need to be collinear if they weren't already. Alright, now it's time to start dimensioning our model. Let's go back here and look. We've got 2 meters between A and C, 2 between C and D, and then 1 between D and E. So let's dimension those. That's 2 meters. And 2 meters here. Now you'll notice that clearly this is showing something other than what I just inputted. That's because I'm still working in inch/pounds per second. We can change that to meters. Go back to edit our sketch. And we'll see that now there are 2, 2, and 1, which is what we had input. Isn't that cool? SolidWorks takes care of that for us. So let's add this dimension using Smart Dimension. It's 1.5 meters from here to here on the vertical, so 1.5 meters, and everything else changes accordingly. We can exit the sketch, hit the F button to recenter that for us, and that is the sketch of this crane. Now we need to create weldments, structural members, add loads, fixtures, and run the analysis. Alright, so we're going to go to weldments, structural members. For this analysis, the type of member that we use does not matter. So we can choose anything, and we'll just choose the square tube that I had selected. And actually, I'm going to do something just a little bit different here. Before we go on, we want to scroll down and make sure that we have the corner treatment turned off. It's a neat feature for some other benefits, but for this structural analysis we don't need it on, so we'll turn it off. And we're actually going to say OK, and I'm going to create new structural members using a much thinner, in fact we'll just use a very thin pipe for these. It doesn't really matter what we use, but it looks a little bit more like the real structure. We'll make sure that the corner treatments are off. Alright, so there we go. We've got our structure built. And now it's time to create a simulation. So we go to Simulation tab, start a new study, just call it Static 1. It's a static analysis. and we will see our model appear, and it'll have joints. So purple means that it's connecting or connecting two or more members. Green joints, like the ones here at the end, are letting us know that those are free ends of these structural members. If we open up this part, now this may say cut list or structural parts, but you can open it up and you'll begin to see all of the different pieces. They all default as beam elements. Now a few of these we want to define as truss elements because we know that they are two force members. So let's select these two cables, just the cables. I'll have the control button down, and then there it is, 4. So in the way I built this, 1, 3, and 4, it may be different depending on the order in which you drew your lines. So we want to right click and say edit definition and change those 3 members to truss elements, which means they are two force members. Two force members are our helper members in a frame analysis. And the other 2 pieces are going to remain as beam elements. You'll see that the icons are a little bit different. We've got what looks like an I shape for the beam elements. We've got what looks like an angle shape for the truss elements. Okay. We don't need to edit our joint group because it looks like we've got joints in the right locations, but we do need to edit the fixtures. So we know that according to the problem statement, both A and C are pinned connections. So those are immovable, meaning no translation, but they will allow rotation. And we'll pick those 2. We'll say OK. Now, one little interesting thing about Solidworks is it's a 3-dimensional program, and so everything's trying to be done in 3 dimensions, but we're wanting to restrain this analysis to a single plane. So we actually need to add a little bit more geometry fixtures using a reference geometry to all of these other 3 joints, the 3 that are not already defined. We're going to define them with respect to to the front plane, and we're going to restrain them normal to the plane, meaning they are not free to move outside of that plane. So we've now created a 2-dimensional model. We need to hang a load out here on the end. So let's create a new force at this joint. So we're going to select joints to apply the load. We're going to have to define the plane, so it's that the load is defined referenced to, so the front plane. We're working in SI units, and it's going to be, I think, a 4 kilonewton load. 4 kilonewtons at E down. So that's 4,000 newtons. And right now it's pointing up. I need to reverse the direction to make it point down. And there it is. Okay. So click the green arrow and we're done. Last thing before we hit mesh and run is we have to define a material. We might as well define it to all the bodies. It doesn't matter what we choose for this analysis. So we'll just define it as alloy steel. And now we can mesh and run. And while that analysis is running, it's done. I was going to say, let's look at our solution and see what answers we're looking for. The tension in AB, which is this diagonal cable, is 10 kilonewtons, and the tension in this horizontal cable, BD, is 8 kilonewtons. So 10 and 8, what we're looking for. So let's see if that's what we get. So right now, that's the deformed shape. You can see if that makes sense to you. Let's look at the beam forces. This is going to tell us what the internal forces are in each of our elements. We want forces in SI in all of our beams, or all of our structural elements. So here we go. Up pops this. Now what you'll see, I'm going to click only beam endpoints to declutter this a bit. And we see that we've got 2 structural pieces that have shears and moments listed, but these other 3 don't. And that's because these other 3 are our 2 force members as we had defined. So let's click on one, and we'll see that this structural member 1, which is highlighted here for us, has an internal force of 10,000. Now it should be noted that we want to look at end 2, and that will tell us that it's 10,000 in tension. And if we look at another one, that's the horizontal member BD, I think, 8,000 in tension. So let's just double check again. Yep, 10 kilonewtons or 10,000 in tension and 8 kilonewtons or 8,000 newtons in tension. So it looks like our analysis compares with those internal forces. Now we could also compare the reactions if we had calculated those, but for this particular problem, we were only asked to solve for the forces in those two cables. That's what we did in this solution, and so that's all we have to compare to our Solidworks model. So that's how to create a frame analysis using Solidworks. Now noting that we did have to identify what two force members existed in that frame. So identifying two force members is a critical skill, not just for solving things by hand, but it also helps when we're trying to use computer software to solve these problems. Well, I hope this helped make you a little bit more comfortable with Solidworks, and I encourage you to use it on future problem sets to check your work before you submit it. Good luck.